Hello. In this video we're going to be taking a look at how to use Minitab to compute normal probabilities. So the one thing that you need to be careful of when you're doing this is that you change all of the information, that you change the mean and the standard deviation each time you do a problem. Also, Minitab always calculates areas to the left. So if you're computing a value that's greater than or equal to, you will need to do that conversion that I did when I was using the tables. So just like the tables, Minitab only computes areas or probabilities to the left. So you need to make sure that you're careful of that. So we're going to go through a couple of examples. These are not the examples that are in the instruction sheet. We will go through the central limit theorem example that's in the instruction sheets. But for the probabilities, we're going to do a few different ones. So for the first one, we're going to use a normal distribution with a mean of 100 and a standard deviation of 3.7, and we want to find the probability of values less than 75. So open up Minitab, and you want to go to the Calc menu, and then Probability Distributions, and then select Normal, and it will bring up this box. And so what we want is the cumulative probability, the middle radio button for this one. We will never use the first radio button. We'll use the second one and the third one. So we had a mean of 100. And our standard deviation was 3.7. And we want to do less than 75. So 3.7 for standard deviation. And you can either have a bunch of data in a column over here, but we're just going to input our value right here in this box. And so that was 75. So when you're computing probabilities that say less than, then you just input the information, and then we're going to click on OK, and then it gives us our answer. And so it gives us an answer of 0. So 75 is so far to the left that the probability of being less than that is 0. Now a mean of 200 and a standard deviation of 15, and we want greater than 100. So in order to compute greater than 100, so here's a normal curve. We have a mean of 200, and 100 is to the left of that. And so we want this probability over here, so we need to move this over to this side. And so in order to do that, you need to figure out how far is 100 away from your mean. And 100 is 100 units from 200, right? So it's 100 units to the left of 200. And so we need to move that over here. And when you move that over here, that value is 300. So 100 units then to the right. And so then we would do less than 300. So probability that x is greater than 100 is equal to the probability that x is less than 300. Oops. So, and we had a mean of 200, standard deviation of 15. So calc, probability distribution, normal. And then just select OK. We get 1 for this, and that's just because 300 is so far over to the left compared to the standard deviation, that we get a probability of 1. In the next example, we have a mean of 0 and a standard deviation of 1, and we want to find the probability that we're between -1 and 1. So here we have a mean that's 0, and we want to find the probability that we're between -1 and 1, so in this area. So in order to compute this green area, you need to compute the area to the left of that, and then you want to subtract off this part, and it will leave you with this area in the middle. So that would be probability of x is less than 1 minus probability of x is less than -1. So let's go into Minitab and compute those two. So we want to go to Calc, probability distributions, and then normal. And we had a mean of 0, a standard deviation of 1, and first I want to compute the probability that we're less than 1. Click on OK, and we get 0.841345. And then minus, now we'll plug in -1, so go back to Calc, probability distributions, normal, and now we just need to make that -1. There we go, click OK. And so then we get 0.158655. And then you would subtract those two values, 0.841345 minus 0.158655, and we get 0.68269. The next one, a mean of 50 and a standard deviation of 2.3. For this one, we're doing something a little bit different. This time we want to find out what value has an area of 0.6 to its right. So sketch a normal curve, and we want an area of 0.6 to its right. If you're at the mean, that's 0.5 to the right. 0.6 then is going to be a little bit to the left of the mean, so it should be some value slightly less than 50. And again, Minitab is only going to do values to the left, so if we have 0.6 on the right, then the area on the left would be 0.4. So 0.4 is really the value that we need to plug into Minitab. So go back to Calc, probability distributions, and then normal. And now this time we want the inverse cumulative probability. So click that. And we had a mean of 50. And our standard deviation is 2.3. And our input value now is going to be 0.4. And then click OK. And so now we see that the probability of x being less than x is 0.4. That's what it tells you right there. And that the x value that does that is 49.4173. Alright, in the next example, we have a mean of 0, standard deviation of 1. we want to figure out what value has an area of 0.05 to its left. So here we're just going to plug in that exact value, 0.05. So click on Calc, Probability Distributions, Normal, and we still want the inverse. This time we have a mean of 0. And a standard deviation of 1. And we want the area of 0.05 to the left. And then click on OK, and we see that the probability of x being less than or equal to x is 0.05, so we entered in the probability, or the area, and here is the value, negative 1.64485. Okay, so next we're going to take a look at the example in the instruction sheet for Minitab about the central limit theorem. So we're just going to run through that exact example. And so I think that this is pretty cool. So what we want to do is we want to generate a bunch of samples that come from a uniform distribution. So each of our samples are going to create or have 5 data values in them, and we're going to generate 250 samples. So each row in our worksheet is going to contain a sample, and we're going to have 250 rows. So we want to go up and calc, and we want random data, and we want it to be from a uniform distribution, and the number of rows that we want to generate, in the example anyways, is 250. You're going to be generating a lot more in your problem that you do for the lab, so just be careful that you don't do exactly what I'm doing and turn that in. You need to make sure that you read through the directions for the lab. Your samples will be larger, and you're going to create more samples than what we're doing here. And then you have to tell Minitab where you want to store the data, and we want 5 data values in each sample. So we're going to store our data values in C1 through C5. And we want the numbers to be between 0 and 9. And then you can just click on OK. And we can see that we have data values that are between 0 and 9 in columns C1 through C5, and you can scroll down and see that there are 250 rows. So we can see that there are 250 rows of data in there. Okay, so the next thing that we want to do is we want to stack all of the data. So in column C6 here, we're going to take all of this data that's in C1 through C5, and we're going to put it into this column C6. So we're going to do what we call stack all of these 5 columns into this one column C6. So to do that, we click on Data, and then you want to click on Stack, and you want the first option to stack columns. And the columns that we want to stack are all of them that we have here. So select all 5 of those. And then we don't want to put it in a new worksheet. We're going to put it in a column in our current worksheet, and we're going to put it in C6. that's all we need to do. So select the columns that you want to stack together, tell it where you want to put those stacked columns, and then click on OK. So I think when you do it, you're going to do 20 columns of data, I believe, and you're going to have like 1,000 rows or 5,000 rows. I can't remember exactly how many offhand, but so click out OK, and so now column C6 contains all of this data over here from the first 5 columns. So what the central limit theorem says is that if you take a whole bunch of samples of data, then the sample means, the distribution of the sample means, is a normal distribution. So the next thing that I want to do is I want to take a look at the means for each of these rows. So in C7, I want to calculate the mean of the data that's in C1 through C5. Do not include the C6 in there. So you can do that quickly and easily using Minitab. So we want to go to Calc, and we can do row statistics. We want the mean, and then you need to give it the input variables because you do not want to include C6 there. So we want C1, C2, C3, C4, C5. And you should be able to do this easy. You should be able to just click C1 and then scroll. You'll have to scroll down in order to get all of them when you're doing it for your lab. And then hold down the Shift key and click on C, I think it's C20. And then you can just click this Select button and it will put all of them over there at once. And so now we need to tell Minitab where to put the means, and we want Minitab to put them in C7. And then click on OK. And so now what C7 contains is the mean for each row, C1 through C5. So now what I want to do is I want to look at histograms for columns C6, all of the data together, and column C7, the mean from each sample. So now we're going to click on Graph, and we want to select histogram, and we're just going to do a simple one. Click on OK, and then we want to do C6 and C7. Click on this Multiple Graphs button, and do separate panels of the same graph. So we want this middle radio button selected, and then click OK. And then click OK again. And so we can see that the graph on the left, this is the graph of all of the data. And so it's not perfectly uniform, it's not perfectly straight across. The more numbers you generate, the closer to a uniform distribution this will look. So yours will look probably more uniform than mine does. But we can see that C7 is pretty close to normal. It is skewed a little bit. It's skewed a little bit to the left, but it does have a general bell-shaped curve to it. So, and when you do it with more data values like you have to do for your lab, it should be even more clear that the first set of data came from a uniform distribution and the second set of data came from looks normal, like it came from a normal distribution. It should look more bell-shaped. So again, just to run through what you're doing. So basically you're having Minitab generate a whole bunch of samples. Each row is a sample of data, and so the example that we did here, we have 250 rows, that's 250 samples. Each sample contains 5 data values, and those are in each of these 5 columns. So row 1, C1 through C5, is one sample. Okay, and then C6 is just all of the data in column C1 through C5 put into one column. C7 is the mean for each of your rows of the data in columns C1 through C5. So C7 is the means of all of your samples, and so we're comparing the distribution of the means of each of the samples to the data itself. So that's what we're doing here, and you can see that the distribution of the means should look fairly normal, like a normal distribution with a bell-shaped curve. So that's it for this lab. If you have any questions, please let me know, and I hope you're having a great day. Thanks.